All right, so today I'm talking to you guys about two different projects. We're talking about Sunn Hemp, which I will explain what that is in a minute for those who don't know. And then I'm also going to be talking about chickpeas, dried peas, and lentils. So all of these are legume crops. I do focus my research on diversifying cropping systems. Specifically, I am interested in dryland cropping systems here in southeastern Wyoming. And even more specifically, I'm looking at how do we incorporate legumes into those rotations in a productive way where we can start to build in not just that crop diversity, but that nitrogen fixation. So these projects are not specific to organic agriculture, although anytime we look at legume incorporation into a cropping system and rotation, it has a lot of application to organic agriculture, okay? All right, so like I said, Sunn Hemp and pulse crops are annual legumes. Legumes are crops that fix nitrogen, right? So typically our crops get nitrogen from the soil, and we get nitrogen into the soil in different ways through biological processes or from applying fertilizer or manure in our cropping systems. Legumes have the ability to form symbiotic relationships with soil bacteria, okay? And they form root nodules. That allows these plants to utilize nitrogen not just from the soil, but also from the atmosphere. So that relationship is allowing the atmospheric nitrogen comes into the soil. The bacteria actually biologically turns it into a usable form of nitrogen for those plants. And then it allows us to grow those legumes without having to supplement with additional nitrogen because they're able to get it from the atmosphere. So very valuable in terms of a crop rotation to have these in your system. Basically, for a crop that you harvest, I think of legumes as being nitrogen neutral. So you don't have to pay for the nitrogen that you're putting into your system, your crop is doing that for you. Sunn Hemp is a forage legume, so this is one that we were potentially harvesting for its biomass. The pulse crops I'm talking about are cool season grain legumes, so we're actually pulling the grain out of that system, okay? So we will start with Sunn Hemp. It is Crotalaria juncea is the genus and species, also known as Sunn Hemp, also known as not that kind of hemp, okay? Not industrial hemp, not related to cannabis, no THC, no CBD, no government restrictions, no certification needed. It's a completely different genus and species. It is a forage legume, not that kind of hemp. I feel like people get interested in my talks about Sunn Hemp because it says hemp, and I have to disappoint them that it's not that kind of hemp. It is a warm season legume. It typically has been used as a green manure crop. So this is a crop that you would grow as a cover crop and then till into your soil for the benefits of that crop. It's estimated that this crop can fix up to 120 pounds of nitrogen per acre in 60 days. Okay, that's under ideal conditions. Do we have ideal conditions? Never. So that's our hope, but we know that it's probably going to be less for us here in Wyoming. It can be used also as a forage and a fiber crop. So it has that word hemp in it because it is very fibrous. It has been used for fiber production. I am interested in it as this forage crop. So I'm interested because it's a legume, but then we are doing work with it, trying to establish if we can also use it for our livestock industry in the state. It is also well suited to dry conditions. In an irrigated system, what I have been finding is when I water it, how I water other things, it gets really mad at me, for lack of better words. So it's a crop that is going to be able, if you use it in the irrigated system, you're going to be able to take advantage of some deficit irrigation I've also been growing it in dryland systems. We've been a little wet the last couple of years, but it's done really well in our dryland production system as well. So we're evaluating it for both systems potentially. Okay, so I'm going to talk to you guys about a study from 2017 and 2018 with Sunn Hemp. This study, I was trying to understand the basic agronomics of the crop. So can I grow it here in the state? I read about it, looked interesting, so I thought let's figure out if it can be useful for us. So the study design, the treatments were planting date. I looked at early, mid, and late planting. So late May, early June, and then mid-June for planting the crop to see how it did. I grew it under irrigation and rain-fed. And then all I measured on these first 2 years was crop growth, so how well the crop grew over time, how much biomass it produced in 60 days, and then what kind of feed value it had. So as I said, I'm interested in it for potentially providing feed to the livestock industry, not just as a green manure crop. Okay, so these pictures are showing us Sunn Hemp growth over time. These photos are from 2019. So we planted our crop beginning of June. This is the end of June. This is the end of August, and then the end of September. Now, this year, we got hail damage on July 5th. We had a bad hailstorm, so it set everything back. I would have expected our crop to look more like this towards the end of August. Okay, so we had a pretty bad setback. The reason I'm showing you this is this picture here, after a month of growth, is about what we expect to see with it. So this crop starts growing really slow. It always looks like it's going to be a failure. It takes it a long time to start to shoot up and produce that above ground biomass. So that's one potential problem with it is early on, it's not going to compete with weeds very well.
What was planting date?
The planting date was, trying to think, this year we were probably around June 8th. We were a little wet or a little later because of how cold and wet everything was. Yeah.
It was still snowing then.
It was still snowing then. Yeah, pretty, not quite, but close.
It was in Casper.
Well, not quite in Lingle. Okay, so this is another way to look at the crop growth. So now those pictures were 2019. This is data from 2017 and 2018. So what I'm measuring here is NDVI. NDVI is our normalized difference vegetation index. Basically what it is we have a sensor. It shoots light down to the canopy and it measures what is reflected back to it. So we can use it for a number of different things in research. What I'm using it for here is to measure canopy closure. Okay, so as our value goes from 0 to 100 or to 1, 1 would be a complete canopy closure. 0 is no green plants on the surface. Okay, hope you can't see. And then our colors, so blue, we have early planting 17, early planting 18. Orange, we have mid planting 17, mid planting 18, and then we have purple is our late planting in 17 and 18. So what we see down at the bottom, we have days after planting. All right, so we see that green cover start really slow and then start to take off. So at about 30 days, and some of my measurements I didn't get in quite soon enough, but at 30 days, we're seeing that late planted crop in the first 30 days starting to close its canopy faster in both years, right? So those purple lines are up pretty high, probably because we're going into warmer soils, you're letting that crop get up and get going faster. Once we move up to about 40 days, you can see that, well, first of all, in 2018, our biomass, our canopy closure was faster. But all of those, we do still see some differences in our planting dates. 2018, you know, we're a little more grouped together, closed up everything about equally by then. But by that point, we really start to see better closure in that canopy. Biomass production. So I will say one thing about this. After we were done measuring it, we gave it to some goats and they thought it was delicious. So that was really nice to see.
I like that type of dirt.
They did very much like it. So with that growth, we don't just want to know how that canopy is closing, but we want to know how much tonnage we're getting off of those fields. So we go out and we harvest biomass after 60 days of growth in the field. So here, this graph, what we're looking at, we have pounds per acre on a dry weight basis. We have blue is our irrigated study, orange is our dryland study, and then we have early, mid, and late plantings, and then 2017 and 2018. Okay, so the first thing is kind of on average, about a ton per acre after 60 days. Not groundbreaking, but not bad either for 60 days. We do see that our early planting dates, both years, lagged behind a little bit, right? Our mid planting dates did very well, one year. And then our late planting dates did relatively well as well. So those mid and late, those June planting dates seem to be performing better for our biomass production. I would say that reasonably, we should easily be able to get at least 1.5 tons out of this crop once I really figure out how to grow it and what I'm doing. So remember, this is me, a researcher. We all know how good researchers are at farming, growing a crop for the first time. So in your hands, you're probably going to get it up to 2 tons without any problem. So good potential for that production. And the other thing is, look at where our dryland production is. So this is in a rain-fed system, no extra irrigation. We do know the last 2 years have been pretty wet. We've had good moisture, we've had good timing of moisture, but it is a crop. In 2016, we planted it in July in fallow ground that had been tilled to within 1 inch of its life. I don't think you could find a drop of moisture probably until you got down to about 10 inches. And we drilled this stuff into it and it grew. Then it got failed out, but it grew. So it has some resiliency and some potential. That to me is really interesting. Okay, and then the last thing with this Sunn Hemp that we looked at, as I said, I'm interested in the actual use of it. So cover crops, awesome, amazing, have a lot of value. Sometimes it's hard to put them on your farm if you don't get something out of it. So looking at that feed analysis for the livestock industry. And what I'm going to do is I'm going to compare that to supreme quality alfalfa. So it is a legume, so it's going to be comparable to an alfalfa crop as far as how you use it in your rations. All right, so this graph is kind of busy. I don't know if you can see, but we got blue here, irrigated, orange here, dry land. Whoops. Early, mid, late 17, early, mid, late 18, and then the same here. And then each of these colors are a different feed measurement, okay? So straight off the bat, there's not a ton of difference in the years and the planting dates and the irrigation as far as that quality goes, okay? If we kind of look a little more closely, so this red line, 22% and above is where supreme quality alfalfa protein needs to be at, okay? So if you look at our red lines, we're all above that. So we're hitting that standard. Our green line is our ADF. So alfalfa supreme quality would be below that line. And if you look, we're right at or below that line for everything. NDF, Again, this is our alfalfa line, and you want to be below it. So again, all of our purple is falling below there. And then finally, our TDN, we want to be just above that line, at or above it, and that's where we're hitting for all of these. So in that 60-day growth, really high quality feed production from this crop, which is also really good to see. So a couple conclusions on the crop. Slow initial growth. So we do use a pre-emergent herbicide when we plant this. That helps a lot, but that slow growth is going to be something, especially in an organic system, that is potentially going to be problematic. Planting date, early June, early mid-June, depending on your conditions, seems to be a good sweet spot for it. You should be able to produce 1 to 2 tons in 60 days. It's going to be dependent on some things. That's what we're able to do at the research station, right? So if I can do it, you can do it. And then the feed quality is really high, equal to that supreme quality alfalfa. Moving forward, some of the questions that we're going to start answering. First, we want to get into this nitrogen contribution. So it's a legume. The value, part of the value in the rotation is that nitrogen fixation. So what we're going to start looking at is it fixing nitrogen? Is it leaving behind nitrogen? Does how we harvest and manage it affect that nitrogen in the system and in the rotation? We're also starting to look into harvest management. So me clipping biomass by hand is not a very effective management tool for somebody who's producing hay. So we're looking at some cutting heights, cutting time, and how that crop responds. We will be doing animal feeding studies this year. Our goats were a great starting point to let us know that animals will eat it, but we're going to do some actual cattle feeding studies this coming fall. We are going to be growing about 25 acres of this at Sarek this summer. So fingers crossed that we can do that successfully. What was that?
The hailstorms go somewhere else.
I hope the hailstorms go somewhere else. It did recover from the hailstorms. It's been hailed multiple times and it will recover from it. So that's good.
We learned that.
Yeah. And then the other question that we want to get into is we do want to start looking at crop mixtures and grazing. So many of you have probably seen Sunn Hemp in cover crop mixes. So it's currently being sold that way. I am looking at it in a monocrop at the moment, but we do want to start to look at, possibly planting it like with teff or a sorghum Sudan and looking at that hay quality and potentially just grazing it instead of having the hay in. That is the Sunn Hemp side of it. Do you guys want to ask any questions about Sunn Hemp before I move on to pulse crops?
Do you think you would get a higher yield if you would have gone more than 60 days, or probably the quality would have went down?
Yep, so the question was, would we get a higher yield beyond 60 days, and how does that affect quality? So that is actually something that we are addressing in our current study. So we have multiple harvest times. We're looking at tonnage and quality at all of those harvest times. So I don't know, but probably.
As a PhD crop physiologist, forage plants in general, as they start to make seed, decrease in quality rapidly.
Right.
So it's taking all the nitrogen plus the leaves, but it is different.
So one of the things, so Roger pointed out that as you go to seed, you're going to start to decrease your quality. So Sunn Hemp is day length sensitive, so it will not flower until your days reach a certain length. So as they shorten, it'll go into flowering. We do not, in the 3 years now that I have grown it, it's flowered. I have had maybe 1% of the plants set pods, and none of those pods have had viable seeds. And that's letting it go all the way until October. So it gets really woody and fibrous by that point, but I don't know for this crop specifically that seed management is going to be a major issue.
I have quite a few. I'll catch most of my questions afterwards, but the big one that I think is important, addressing feed issues is, have you done any alkaloid studies with the concentration of Sunn Hemp, like feeding only Sunn Hemp to high concentration of alkaloids?
No.
No.
Because I am not an animal scientist, so a lot of the feed stuff, that's about the extent of my knowledge on where we need to be. So
The goats like it.
The goats like it. That's good. I'm told by our animal scientists that if goats will eat it, anything will, which I thought goats ate everything, but that shows my knowledge on
very
animals.
picky. They're very picky.
Yeah. Okay, anything else on Sunn Hemp? Yes, sir.
It'll always be a seed purchase. You'll never be able to make seed here.
Yes, so the comment was it'll always be a seed purchase because you can't make seed. So right now, I get my seed from Green Cover. It's $1.50 a pound. I plant at about 40 pounds per acre. That is not necessarily what the recommendation, that's my current state of knowledge for how I've been managing the monocrop that I'm growing. But there could be some differences in your seeding rate or if you're doing it with a mix or not. The University of Auburn and the University of Florida have breeding programs for Sunn Hemp. And part of that program is to develop varieties that they can produce seed from more easily in the US. So as those programs develop, right now the seed is imported from India, is where we get almost all of the seed from. There is a variety called Sun Gold that they produce in Hawaii, but it's very hard to access it. So there is other research emphasis on developing this crop for seed production and for more accessibility here in the US.
Being a legume, did you use any inoculant on the seed?
We do use inoculum. We use a peanut inoculum on it. That's what happens. So let's go backwards. I want to find a picture of a plant. What else will do? So to me, these plants are a really nice, dark, healthy green color. We apply no nitrogen to the field. So far, I have not assessed soil nitrogen. I have dug up plants and looked for nodulation and have not found it, but not all plants form the classic nodules. But if I planted corn in the same field and didn't apply nitrogen to it, it certainly would not be this nice green color. So I've seen no nitrogen deficit in this crop as I've grown it without any supplemental nitrogen. And our soils at Seric, we typically have anywhere from 10 to 30 pounds of residual nitrogen in our soil profile. So they're pretty deficient. And yes, I do inoculate because it's not going to hurt.
I'm not sure if peanut is the same, but I planted Sunn Hemp a couple times as well on my farm, and I always used the cowpea variety inoculant, which made it, and I had big nodules.
Did you have big nodules? Okay. Yeah, I think they sent us peanuts this year. I'm not sure what they've sent us in the past, but that's something to look into. Maybe we'll try switching it up or try a couple of that. That'll be the next round of studies is what inoculum is the best to use with it.
But if it was nitrogen deficient, the feed quality wouldn't be as good as you should.
Yeah, high protein.
Yeah. Yes, it's getting nitrogen from somewhere. Where is to be, I can't say for sure. My assumption is that it is doing its job as a legume and fixing some of that nitrogen. How are we doing for time? So 11 o'clock. 11 o'clock, okay. All right, so we're gonna move into our pulse crop study. So this study took place in 2018 and 2019. It's a dryland only study, so there's no irrigation in these fields. And what we were looking at is, again, I know that a lot of guys are growing some of these crops and playing around with them, but we wanted to get a little bit more of a robust data set of what is the yield potential of chickpea, lentil, and field pea in Wyoming's dryland crop rotation. Wanted to understand a little bit more about the water use of those crops, what their demand is, what they're leaving for our subsequent wheat crop, and then try and start to understand nitrogen additions to the dryland system. So this study, like I said, we had chickpeas, lentils, and field peas. We again had 3 planting dates to look at what our ideal planting date was. Each crop, we seeded 2 different varieties. We also seeded at 2 different seeding rates. The seeding rate, especially for the dryland, trying to understand if we could decrease our seeding rate, decrease the water demand, but maintain a high yield demand. Long story short, on all of those treatments, didn't matter. Variety pretty much didn't matter, planting date pretty much didn't matter, seeding rate pretty much didn't matter for the data that we got. So as we go through this, that's the story of those things. So I'm mostly going to focus just on how the crops did for us in the study. So we'll start with yield. So here we have our chickpea, dry pea, and lentil yield, 2018 and 2019. And then our yield is in pounds per acre. I'm sorry the scale is kind of weird. This is from my grad student's thesis, and it's in kilograms per hectare. And I couldn't change the axis, so I had to just do a quick conversion and line it up with the line. So that's why those numbers are not nice and round. Yes, sir?
These chickpeas, garbanzos, the big one?
Yep.
Thank you.
Yeah, the kabuli. Yep. Okay, so again, planting date, seeding rate, and variety did not come in as a significant effect on our crop yield. Our years were different, which is not shocking. And really, we're not comparing crops to one another because we have different yield expectations, like comparing corn to wheat, right? We don't do that. But what we can do is compare our yield to some other yields that are kind of common for dryland production systems that do grow these. So these stars are yield averages that were published by North Dakota Extension in one of their field guides for pulse crops. So our chickpeas were a little bit short on our yield goal. Our dry peas were kind of right where we would want and expect to be. And then our lentils, 1 year we did terrible. Our second year we got a lot closer. So this may look discouraging, but again, what did we learn about the Sunn Hemp? I am an academic, therefore not the best farmer. So we had some stand establishment issues. We got about 40% of our stand that we wanted. So that affected our yield a little bit. Lentils in our first year, we did not realize how much grasshoppers liked lentils. So that affected our yield quite a bit. Our dry peas were the least problematic, although this last year they did get bacterial blight with how wet it was. So that affected that yield some. And then our chickpeas in 19 also got some ascochyta blight that we had to deal with. So again, initial work yields a little lower than we would like them to be, but I think there's a lot of room for improvement in growing these crops. Okay, so now we'll talk about soil available water. This is at wheat planting. So we planted our crops in April, harvested, some years June, or not June, July, other years September. And then we went right back into wheat after we harvested this crop, so a continuous crop rotation. And so we measured our soil moisture right before we went into wheat planting. So this graph is showing us our soil available water in millimeters, and then this is our soil depth. So as we go down, we get deeper. So this first line here is at 10 centimeters, which is about 4 inches. At that depth, we really didn't see a separation. We've got chickpea, dry pea, lentil, and fallow is what we're comparing. So the 3 crops compared to a system without any crop in it. So at that shallow depth, by the time we were going into wheat, we didn't see a difference in our soil moisture. Our moisture was low, but it was low everywhere. As we go deeper, down to 30 centimeters, that's about 12 inches, we still see all of those treatments grouping together. Once we start to get deeper than that, then we see a separation. So as we go down to 60 and 90, we see that our chickpeas and lentils at 60 did pull down our soil moisture more than our other crops, whereas our dry pea and our fallow were still equivalent at that depth. Part of that reason is probably because the dry pea got harvested a lot earlier, gave that deeper profile more time to recharge. Okay, and then as we get down to 90, it kind of gets confusing. I kind of ignore this because once we get below 60, our soils start to vary so much as far as how sandy they are, or if we can even get down to that depth, that's just kind of fudge. But the take home is at that top foot, our moisture with this grain crop in the system didn't seem to be depleted any more than our fallow, and then our dry pea at that deep depth was comparable to fallow. So in terms of introducing it into a rotation and trying to conserve your water, this would indicate that it shouldn't hurt you that much, with the caveat that we've had moisture the last 2 years. Okay, and the nitrogen addition to the dryland system. This is a difficult thing to measure because we have a crop that we are harvesting for grain. All of our nitrogen is pretty much tied up in that grain, right? So it's not so much that you grow the crop and you get 200 pounds of nitrogen in your soil. It's that you might get 200 pounds of nitrogen in your grain that you're taking out of the field. So it's kind of hard to track all the nitrogen and where it's going, but we're gonna try to do it, and I'll just show you guys one set of data that I think is kind of the most compelling. So nitrogen addition, these are nodules. For those of you who have not seen nodules, they're these little tumor-like masses on the roots. And if you grow legumes and you haven't done it, go dig them up. Once they're kind of at flowering, you should be able to find them. And then what you want to do is break them open and squeeze them, and there should be kind of like a reddish pink ooze that comes out of them. That means they're nice, healthy nodules that have bacteria in them, and they're doing their job. Okay, so for the nitrogen, another variable that we layered on top of this study was we split our plots, and half of the plot we terminated as a cover crop. So this is a chickpea plot that we had. This side here was taken to grain. This side here was terminated. We chemically terminated it, but it was terminated right at peak flower as a cover crop treatment. The reason that we did this was I was interested in, one, in a dry year, can you conserve moisture? And two, do you still get a positive nitrogen credit if you terminate as a cover crop? Because our years were so wet, the moisture component didn't really pan out because moisture wasn't really an issue. So that's why I didn't talk about that one. But as far as nitrogen, so what we're looking at here, this is average nitrate changes in the top 4 inches of the soil. We measured in March before we planted anything, and we measured in about October before we planted our wheat crop. Okay, so that's season nitrogen. And then what we did was we took the starting nitrogen and the ending nitrogen, and we looked at the nitrogen change. So a positive value means our nitrogen increased, a negative value means our nitrogen decreased. So this chart here, we've got a few things going on. We've got chickpeas, dry peas, and lentils. We've got our cover crops. And for this, the planting date did make a little bit of a difference. That's why it's got the early, mid, and late for all of them. But we're gonna kind of group our brains just looking at the cover crops. And then we've got our grains for each of them. and then we have our fallow, okay? So we're trying to compare how does that nitrate in our soil differ with these different treatments and our different crops. I like to use these color coding, highlighting to try and help me group these mentally. So anything shaded green has a higher value. So higher soil nitrate, more nitrate added to the system. Anything grouped red is a little bit lower. So what you can see is that for our cover crops of our chickpea and our lentil, that cover crop treatment, we were getting increases in our soil nitrate at the time of wheat planting. And they compare just as well to our fallow treatments, if not more. So we're getting that nitrate addition to the system. With our grain crops, you can see that we're in the negative, right? So we're getting either not very much nitrogen added, or in some cases we're losing nitrogen or nitrate from that top 4 inches. Part of this is because we're harvesting the crop. Part of it is going to be because that crop has only been out of the system for a few weeks, so you're not starting to get that nitrogen mineralization and breakdown and release back into the system, okay? But the take home is, it does appear that managing as a cover crop is going to get you a nitrogen credit at your time of wheat planting. But also that really, our grain crop, we're not that much lower in our nitrogen than we are relative to our fallow, okay? So you shouldn't be depleting your system by growing these crops. Conclusions on the pulse crops. Our yields were lower than expected. We kind of talked about that, but I think there's really great potential for them to yield well. We'll continue to work on that. Water use, our fallow did use the least, but our dry pea was really pretty competitive, so we really didn't see a water hit with the dry pea grain. Chickpea and lentil had a little bit depletion at that 2-foot depth, but hopefully that's something that would recharge over your winter. And then our soil nitrate did increase in those cover crop plots. So especially for an organic system, if it's something that you're looking at growing as just a cover crop, it does seem that having these in the system and then terminating them will give you a nitrogen credit going into your wheat crop. All right, that's what I've got. We are at 11:11, so I've got time to take any other questions you got, I think, if you have any. Yeah.
With your, say your dry peas, for example, did you do any studies besides the nitrate? Did you see how much phosphorus they might have pulled out of the system or calcium they might have pulled out of the system?
Yes and no. So the question was, did I look at anything other than nitrate? So we did a complete soil test at both sampling dates, and I have not gotten to that data yet. So we have information on phosphorus and potassium and organic matter and cation exchange, and that's the bulk of them. So that's something that we're looking into more, but I don't have the data at the moment. Sorry.
So don't you think we're going to get a pretty good nitrogen credit for the next crop? Because I know like alfalfa, irrigated alfalfa, you'll get 90 pounds in the next year. You can't measure that. You just get it. I think the nodules take time to break down.
They do take time to break down, yes. Ideally, we would measure in the fall,
Yeah.
and then we would measure in the spring and look at what that nitrate is doing over time. We do also have what is called potentially mineralizable nitrogen that we measured in the system. So that is nitrogen that is in the soil in a form that's not currently available to the plant, but can be converted to available nitrogen for the plant. So there's a couple students who have posters downstairs who have data from their studies on that measurement. And it is a way for us to try to better assess that nitrogen pool that is in the soil and in the system. So I do also have that data, but it is not done being pulled together yet.
Thank you.
On the Sunn Hemp, did you guys feed it to any of the cattle at Sarah?
So she asked if on the Sunn Hemp we have fed it to any of the cattle at Sarah yet. No, because one, the cattle that are in our feed lots are all on studies, and they get really mad if I sneak over there and give them some of my crop. And our cows that are out in the pasture don't really come up to you and get handfuls of food. This year, this fall, we will be feeding it to our animals. So they will be specifically on a feeding study. We will be doing different mixes with it. We'll be looking at palatability as well as gain on those animals.
You're gonna bail it?
Yes, the intention is to bail it. We'll see if it works, but yes, that's the plan.
Do you have a sense of how much residue is left behind, or how easily the residue or the root ball will break down for each of these crops?
So the question was about the residue retention. For the pulse crops, not much. I mean, after we harvest, it blows away pretty quickly. So whatever is left in the soils will stay there, but like most pulse crops, that residue doesn't seem to persist very long. For the Sunn Hemp, so harvesting it as a hay crop, you're going to remove a lot of it, but it does have the potential to regrow. So there is potential that if you harvest it, it'll have some regrowth that isn't enough to harvest. That'll kind of help protect that system. And then those stalks are very fibrous, so they're going to stick around for a long time. That's one of the struggles with managing it as a cover crop, is if you let it get too big, your carbon and nitrogen ratio starts to shift too much, and those fibers take a long time to break down, and so you don't get the credit as fast as what you want with a green manure.
But in the standpoint of erosion, that's a good thing.
Yes, from the standpoint of erosion, that's a good. So those stalks, you know, they easily get. Which finger do you want? They easily get, you know, the diameter of my finger, which may not seem that thick, but they're tough, they're hard, and they do. Like I just drove by our field, and the stuff I didn't harvest is still standing out there. So that residue, especially on the Sunn Hemp, is gonna hang out for a while. Yeah.
Did you measure the difference in the carbon in the soil? You might look at that. Like a lot of people say, with alfalfa, you fix nitrogen, and that's been the main thought process. But if you go back and check the carbon, most of the jump you get in the next crop will be the carbon rather than the nitrogen.
Mm-hmm. Yeah, so we did not measure the carbon in the soil. It's a good point, and that soil organic carbon pool and that soil organic nitrogen pool are definitely valuable in looking at how your rotation cycles everything. Honestly, there's two reasons probably why we didn't do it. One, I didn't think about it, and two, it's expensive. So it is something to moving forward as we get into bigger studies with it to certainly try and track and measure with these crops.
The kaboulis, as far as organic crops, that's probably the toughest one I've ever come up against. Disease package that rots in the ground before it comes up.
Yeah.
It doesn't have a canopy, so you have a lot of weed trouble. And then once you get it up and you're ready to harvest, if it rains, it greens up again.
Yeah.
It'll make you want to slap the ground. It's
Yeah.
nasty.
So that is some benefits of using a conventional system. We use a seed treatment. It allows us to plant early because we can go into those cooler soils and have that seed protected. So I know organic producers with those chickpeas, you know, I say we're planting in April. an organic producer, you're looking more at June. Even though it's a cool season crop, you want your soil temperatures to be warm so that that seed gets up and out of the
You
ground
lost your production
fast.
because when it's flowering, you're in heat.
Yep.
So it's a tough crop.
Yeah, and they do, you know, they keep coming out with new genetic packages on all of these crops as we, you know, the last few years, the pulse crop market has kind of been up and down with some things that are out of all of our control. But I do think there's going to be a continuation of pulse crops to be in demand as our world populations grow in areas that you have vegetarians, as you see other populations start to shift to more plant-based protein diets. So I think the breeding on these crops will hopefully continue in a way that'll give us some technologies to fight some of those disease issues without needing to use, you know, chemical pesticide controls for it.
The other
There's a
side
breeding
of it,
program at Montana State, I know that's working on it. So.
Yep, yeah. So she just said there's a breeding program at Montana State.
I had a question associated with your dry peas that you produced this year. You said you had an issue with associated blight coming in, or one of the blights coming in,
No, that was the chickpeas.
the chickpeas. What was the spacing on those?
Oh, so we drill them, so it's 7.5-inch row spacing. And then we did do stand counts and population density. I would say we had a plant every 3 to 4 inches.
On a 7.5-inch row?
Yeah,
Just curious.
yeah. And one of our varieties, we grew Early Star and Carver. And I think one of them fared a little bit better, but I don't remember which one off the top of my head.
You can actually get an ascochyta blight rating when you on the seed.
Right.
And you want that to be like 0.
Yeah.
The newer varieties are much better than the older.
if you store them, they get a lot of worms.
Can you tell me with the Sunn Hemp, do you know, is it bloating or non-bloating?
I don't know. So he asked if the Sunn Hemp was bloating or non-bloating. And Lauren, isn't that something you guys are talking about maybe trying to look at? Yeah. So there's a new test that they have in the animal science department to measure that on biomass. And so that's something that we're looking into.
I have one other question for your Sunn Hemp as well. After you went in there and you did you clipped it off, right?
Mm-hmm.
Did you notice or did you do any experiments with the nodulation after you applied that stress factor to the plant?
No. So the question was, did we look at nodulation post cutting? So the design we had for this year's study was that we were going to go in and start harvest at 35 days after planting through, I think, 75 days after planting. And we were going to re-harvest. We had multiple harvest heights, so we were looking at regrowth. We dug nodules pre-harvest, and then at the next harvest, we were going to dig more nodules to see if any of that changed. And then we measured nitrogen at the end of the season. Unfortunately, because this year was cold and wet, two things that Sunn Hemp did not like. I didn't start harvesting until 55 days after planting because my crop just took that long to get going. And so that then meant that we were too late in the season to do any of that secondary stuff. So it's a great question. How does that harvest affect your crop and your nodulation and your nitrogen production? I'm trying to look into it, but right now I have absolutely no idea. Sorry. It's a good question. They're great questions. I wish I knew all the answers.
Okay, any other questions? Okay, Carrie, thank you very much. That was very informative and fun, so appreciate your information. Carrie will be around for a while, so if you've got questions, and you'll be here for lunch.
I will be here all day, so if you have any other questions, you can grab me and we can chat more. So, thank you guys.
Hey, Carrie, I got a comment for you. It's not so much a question.
Oh, jeez. Oh, jeez. All right.
Has anybody else planted Sunn Hemp in here before?
I shied away from it because I live in, I was a farmer in southeast Wyoming, wanted to try it, and I got scared away, and then I'm so glad that you did some research because we didn't plant it.
It's got a really high cost to get it in the ground, right?